Hi everyone, today we are going to be going over circles, and to get started with that we actually need to go over a couple definitions. So first of all, I'd like to start off with the definition of radius. So a radius is defined as any segment that stems from the origin of the circle to the outer edge. So let's draw a picture of what that looks like. So if we go to our mouse here, we take our line segment, start from the origin, and go all the way out to the outer edge of the circle. So right about here. So that is what a radius is. So another definition that we need to go over is what the diameter is. So talking about diameter, that means it's a line segment that stems from both outer edges of the circle, so from edge to edge, and it passes through the center. So I'll go over an example of what a diameter looks like and what a diameter doesn't look like. So for example, on this right circle, a diameter passes through the center of the circle. So there is one diameter. Perfect. An example that is not a diameter, I will put in, let's go gray. An example that is not a diameter is something that looks like this. And the reason that's not a diameter is because it does not pass through the origin. It may touch both sides of the circle, but it does not pass through this middle part, which is the whole point of a diameter. So let's undo that piece. So comparing these two circles, let's undo that really quick. Let's grab this guy and let's move him over. So let's put him over here. So if we're comparing these two things, let's look at what happens when we cover up half of our diameter. Remember, the diameter is the circle on the right. So if we take our eraser, and if we undo this little portion of our circle, let's undo that. If we undo that part of our diameter, we're only looking at half of it. What does that remind you of? You should be screaming, oh, that looks like a radius, which is what we have on the left. So let's think of a formula that might be able to relate our radius and our diameter together. So remember, this is exactly half. If we covered up one half of our diameter, that looks exactly like a radius. So another way we can say that is letting D be our diameter. So D stands for diameter, which is this guy on the right, and R, I'll put diameter, and the radius, sorry this looks so unprofessionally written, I'm doing the best I can, radius in there. So with D being our diameter and R being our radius, which is again over here on the left, we can write a formula that looks something like this. Remember, it takes two radiuses to make up our diameter. So if we were to write some sort of arbitrary formula for that, we could write D equals 2, because we need two radiuses to make up our diameter, times R. So let's go over an example problem of that. So let's say that we have a radius of 5 centimeters here. What would our diameter be? Well, let's look at our formula. So we have D equals 2R. So if we plug in R for this, so if we plug in 5, we're going to get D equals 2 times 5, which is going to be 2 times 5 is 10, so our diameter is 10 centimeters. So nothing too complicated. Let's move on to some more complex terms. So let's clear this page. Now let's talk about circumference. Now, I'm going to put this in blue because blue is pretty. So circumference is defined as the distance around the outside of a circle. Now, let's break that down for a second. Do you all recall the definition of perimeter? That is the distance. Oh, what is going on? That is the distance around some straight-edged figure, like a square or a rectangle in this case. So to find the perimeter of this rectangle, we'd add up this side, this side, this side, and this side. However, with a circle, there are no edges, so that makes our situation just a little bit more complex. And don't worry, you'll be discovering a formula to calculate the circumference of any circle. But for now, we're going to just go over the definition of circumference. So again, it is the distance around the outside of a circle. So think about walking around this circle. That would be your circumference. That is exactly what your circumference would be. Now let's go over the area of a circle. You guys remember the area of a regular rectangle or hectagon, pentagon, all of those wonderful things. The area of a circle is the exact same thing. It's just the amount of area you can fit inside of a circle. So the amount of blue that I can put in this thing. Or if you think about it in terms of how many people can I fit inside a classroom. So things like that. So this circle, the one that is not filled in, is the circumference of a circle. Again, sorry for the bad handwriting. I have to do this with my mouse. And the filled in circle over here, I'll put that in a different color. We'll put this in pink because pink is pretty. We'll say that this is the area of our circle. So that is all for today. If you guys have any more questions, there is a formal page where all these definitions are written down on the Canvas website. So I want you to try and use those if you're a little confused and couldn't keep up with what I was saying. If you have any questions, feel free to email me. Your next activity will be discovering formulas for the area and circumference of a circle. So work through those and send me any questions that you may have. All right, thanks guys.